Okay, so bearing in mind that before, way back when I had Ohio Aqua Farms, we were dealing with 10-foot long, 6-foot high, 3-foot wide grow systems, but the universal thing about those systems is it all broke down to a growth channel, and there would be multiple channels on multiple tiers, right? So from the ground up, so 3 foot, 5 foot, 7 foot, whatever. So it's the same theory that we had before. Fish tank. Now, in the future, this would be full of edible fish like tilapia or perch or something of that nature, right? Even freshwater prawns, okay? Crawdaddies, whatever you want to call them, crawfish. There's a pump submerged here that feeds in, and it is all controlled by this. This is a 8-bit microcontroller, right? Essentially a sonar machine, right? Or the same technology that got Neil Armstrong, into outer space and to the moon and all that good stuff, right? 8-bit technology. But that's enough technology, especially on a dual-core board, paired with this. This is a development board, and those black channels in the middle with those pin slots are designed to align with the pins here. And then what we have, instead of just a limited set of pins on one 8-bit board, right, 30 pins here, we now have 90 pins, right? So each one of these, if I can get the light on it correctly, you can see signal, SVNG, signal, VCC, and ground, right? So each one of these is essentially a controller that can control something like this relay switch here. Now it's this relay switch here that controls the pump that's submerged underwater, right? That's where this red line here goes up to the switch, the relay, and goes down from there to that little black micro pump, right? That micro pump feeds the water up here. When this module that I built, this is a sensor, and it works on resistance, right? Electrical resistance. And so there's a 10K ohm resistor in here, and there's a program on the control board, or the microcontroller, that reads it and sends a signal out to the relay. When this pin dries out, right, I can program it to a certain resistance, right? And once it meets that resistance, let me see if I can get it to trigger. I'm going to slowly pull this out. I'm going to follow this line here, right? And that's just from removing this sensor that I built to air, right? And so with this board, a continuous program can be written to monitor multiple grow beds on one vertical system that's like I had before, the modular systems. 6 feet tall, 10 feet long, 3 channels on each side, all holding plants, all now regulated by this. And up in this corner, you'll see there 3.3 volts, 5 volts, and ground. Now those are standard power outlets, right? And right above that you see the jumper, 5 volt, 3.3 volt, that little yellow jumper there. That determines how much voltage this board kicks out. So it can run up to 5 volts. Now with a boost converter, we could get that up, I could get that up to 10 volts, right? Reasonably, 9-10 volts. Basically a 9-volt battery. And again, a 9-volt battery, essentially what powered the dang on computer that was on our first little space pod, right? So, yeah, it looks like... the power. So from the 3 volt, or 3 volt and 5 volt constant power output here, right? I just directly wired in, because we're indoors. We don't have anything to create standard environmental conditions. In order to inspire rapid evaporation in the soil, to dry it out, get it through normal cycles, you can't be in a stagnant environment. You'll turn it into swampland, right? Rot the plants, rot the roots, rot the seeds. Can't have that. So there have to be cycles of when this dries out to prevent mold and bacteria buildup. So on that standard hot pinning ground, I tore a fan out of an old computer, and I got a bunch of them. I've torn parts out of everything that wouldn't work anymore. But now I have wind and I have rain. I'm indoors, so I have temperature control. I have right now a low intensity grow light growing over this, but I'm going to be swapping that out for this high intensity grow light that I have down here, right? And that, I mean, that looks pretty shaded there, and then you add this light. Now look, that's a grow light, right? And that's LED. So this light here is it's only pulling out 5 volts, right? So this is like an 8-watt bulb, right? So power consumption, we're talking micro voltages in comparison to what we were doing before with large pumps and submerged in large tanks where we had to have circuit boards put in, and we were drawing 110 volt power to run the systems. And now we've cut 110 volt consumption, and God knows how many amps per hour, 30 plus amps per hour times each piece of equipment, 20 amps of power, 7 amps of power. These are running 1 to 1.5, 2 amps, right? That's it, right? This was the direction Ohio Aqua Farms was supposed to go before Mike decided to grow the hottest peppers in the world and essentially turn Ohio Aqua Farms into a worm farm that he still hasn't done anything with. But I have managed on my own, no external funding, everything out of my own pocket, all research done on my own, all documentation done on my own, no partnership, no confusion, no nothing. I'm back. I'm back, bro. I'll have this up and running in no time. Oh, I got plenty of wood. I'm going to be building my first tower. All that'll be done. I've got 170 seedlings planted and going right now. Huge stuff. It's about damn time.